Now let us see exercise 7.3 fourth question. Now see the question. A solid consisting of a right circular cone of height 12 cm and the radius 6 cm standing on hemisphere of radius 6 cm is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of the water displaced out of the cylinder if the radius of the cylinder is 6 cm and the height is 18 cm. So here in our question they have given one cone you have. Okay, so one right circular cone you have. One right circular cone and that height of the cone they have given, that is 12 centimeter they have given. Okay, so after the radius they have given, the radius, know that this is the circle part of the cone, so that is the radius. So radius 6 centimeter they have given. So the next one, it is standing on the hemisphere. So this cone shape standing on a hemisphere. Okay, so this solid standing on a hemisphere. So attached and draw. So one hemisphere. Okay, so now this is a hemisphere. So one cone shape, the height of the cone they have given, that is 12 centimeter and the radius of the cone they have given, that is 6 centimeter. So after it is standing on a hemisphere. Okay, so attached and draw. So now here, so this one, so here also the radius they have given. So this is a circle part. So this is radius 6 centimeter. So after this also radius only. So know that from center to this part. Okay, so that is also 6 centimeter only it will come. So the next, so that means this height. Okay, so radius. So that is 6 centimeter, totally 18 centimeter. After one cylinder shape you have. So one cylinder shape you have. So then this solid full of water you have. Okay, so this full of water and this height of the cylinder they have given, that is 18 centimeter they have given. Okay, so that is 18 centimeter they have given. Now here this solid, this combined solid, this solid we have to place it into the cylinder. Okay, so this cylinder already we have the water. Now we are going to place this combined solid in the cylinder shape, into the cylinder shape. Okay, so when you placed this combined solid into the cylinder shape means the water it will displace. Okay, so it will come out only. So in our question they have asked to find out, so the volume of the, find the volume of the water displaced out, how much water, how much capacity of water it came out. Okay, so that one only we need to find out. So then how we can find out? So here together I have drawn. Okay, so separately I have explained. Here one cone shape. So after that cone shape standing on a hemisphere. Okay, so here the height of the cone they have given to 12 centimeter and the radius 6 centimeter they have given, and the hemisphere radius also they have given, that is 6 centimeter. Hemisphere, this radius, this also radius only. So that means this height 6 centimeter. So totally 18 it will come. Now this combined solid we have to place it into the cylinder solid. Okay, so the cylinder we have full of water we have. So when you place this one, so some water it will come out only. So that capacity of water, how much capacity of water displaced only we need to find out. How much capacity of water will come out, that one only we need to find out. Okay, so now see here how we can find out. So easily you can find out. So now look at together I have drawn here. So when you place this solid only, some water it will come out, so it will displaced out, it will displaced out. Okay, so now how will you find out that capacity, how much water displaced out, how we can find out? So this capacity, this volume, this combined solid volume if you find out means, then easily you can say how much water it will come out, because when you press this solid only some water it will displaced out. Okay, so then this volume if you find out means you can easily tell how much water displaced out of the cylinder. Okay, so now this volume how we can find out? Volume of the cone plus volume of the hemisphere. So both volume if you add it means you can find out. See the solution. First you have to write in cylinder, three shapes you have. So in cylinder first what you know that the radius you know that. Okay, so in the cylinder shape we know the radius, so that is 6 centimeter. So r is equal to 6 centimeter. And then h1, so why we have taken this one h1 and the next one h2? Because here the cylinder part also, the height of the cylinder you have, after the cone shape also height of the cone they have given. So both height we will confused, better you have to take height of the cylinder as h1 and height of the cone as h2. Okay, so in cylinder radius first you have to write, that is 6 centimeter, and the height of the cylinder, that is h1, so h1 is equal to 18 centimeter. Next, in the cone shape, the radius we know that, so radius is same only, so all the radius same only. So the radius, no need to take r1, r2, r3 like that, because the radius is same. So our radius r is equal to 6 centimeter and height 2. So already we have taken the height of the cylinder as h1. So now height of the cone we can consider as a h2. Okay, so now that is 12 centimeter. After the hemisphere, what do you know that? The radius we know that. So that is r is equal to 6 centimeter. So now we need to find out how much water, how much capacity of water, how much volume only we need to find out. How much capacity of water displaced out only we need to, displaced out of the cylinder we need to find out. Already I said volume of this solid, combined solid, if we find out means, you can easily tell how much water displaced out of the cylinder. Okay, so this volume only we need to find out, because when you press this combined solid only, the water will come out. Okay, so we have to find out this volume only we need to find out. So volume of the cone plus volume of the hemisphere. So I have to write volume of cone plus volume of hemisphere. So volume of the cone formula, that is 1 by 3 pi r square h2. Okay, so volume of the cone we have taken h2, 1 by 3 pi r square height, but we have taken the height of the cone h2. So 1 by 3 pi r square h2 plus the next one hemisphere. So volume of the hemisphere 2 by 3 pi r cube. So that is the volume of the hemisphere. Now 1 by 3. So this both part. So which is common? So here pi having, so here also you have pi common you have take, here r is common, here also r you have. So r square, here r 2 times, here r 3 times, the lowest power only we need to take. So r square we have to take. The next one here 1 by 3. So 2 by 3 also you have to write, 1 by 3 into 2 you can write. Okay, so then 1 by 3 is common. So 1 by 3 also you have to take it outside. So now the remaining 1 by 3 pi r square we have taken outside, the remaining h2 plus 2 by 3, 1 by 3 we have taken outside, the 2 only it will come, the remaining. 2 into pi r square we have taken. So 1 r remaining it will come, so that you have to write. Now 1 by 3 into, can you apply the value? Pi value, that is 22 by 7 into r square. R square we know that the radius are 2 times. So 6 into 6 you have to write. The radius is 6. So 6 into 6 into h2. h2 here what is it? 12 centimeter. 12 plus 2 into r. So 2 into the radius r 6 centimeters. So 2 into r. So 1 by 3 into 22 by 7 into 6 into 6 into 12 plus 2, 6 are 12. 12 plus 12, 24. Now you have to multiply and divide. Any other thing you can cancel. 3 and the 24 you can cancel it. Okay, so 3 and 6 also you can cancel. Otherwise 3 and 24. So 8 3s are 24. So any other part you can cancel it. We cannot cancel. So multiplying 22 into 6 into 6 into 8 divided by 7. Okay, so now if we multiply we can get it 6336 divided by 7. After dividing by 7 we can get it 905.14. volume only we have found it, so that's why we have written the unit centimeter cube. So now we have to write volume of water displaced out, so that is 905.14 centimeter cube. Okay, so keep it in your mind. When you press this shape only, this combined solid only, the water displaced out. Okay, so this volume if you find out means, you can tell how much water displaced out of the cylinder. Okay, thank you.